Okay, so now that we've looked at square numbers, which I hope made a lot of sense to you all, we're going to look at a little bit of a trickier one, number pattern that is, a trickier number pattern, and talk about triangular numbers. So if we take a look at the three diagrams, they're similar to the last three that I drew, but they're different. Obviously, they're triangles. Okay? So once again, I've arranged these dots, I've attempted to arrange them to form a triangle. So let's see if we can interpret these diagrams a little bit. As we did with square numbers, we start off by looking at this expression. T, we can assume stands for triangle, that's pretty straightforward. T sub 2 equals 3. And as with the last diagram, the 3 refers to the total number of dots. But what is 2? So recall when we were doing squares, right? S sub 2, let me just draw that one again. S sub 2, which was equal to 4, was a diagram like this, right? And the 2 referred to the number of rows. But what does it refer to in this triangle? It's not so straightforward. Let's take a look at T sub 3. Equals 6. Well, we can check in 1, 2, 3, 4, 5, 6. Yeah, that's the number of dots. So we're comfortable with this number on the right side of the expression. But again, what does that 3 represent in this diagram? All right, and as we work over to this way, what does that 4 represent? More importantly than just specifically this number, the 2, the 3, and the 4, how are these diagrams growing? I want you to notice some things, right? If, for example, I would make the argument that each of the previous diagram is sort of embedded in the current one. So if I go to T3, well, I notice T2, if I draw this dotted line, is right there, right? So I can think of T3 as T2 with an extra row underneath it. Does it hold for the next diagram? Maybe. Again, we're studying patterns here. And if you recall, when we were looking at the square number patterns, we ultimately were able to come up with a formula and figure out that if I gave you any number n, you could tell me the total number of dots in the diagram as being n squared. Looking at this one, I think it's a little trickier, right? Well, if I give you 2, how do you get to 3? If I give you 3, how do you get to 6, etc.? How are these numbers growing? With the dots, I just simply added an extra row and an extra column. Well, how are the triangular numbers growing? So I would encourage you to just study these 3 diagrams. Maybe pause the video somewhere around here and study them for yourself. Let me just get this dotted line out of here, not to confuse things. And that really is my question I have for you guys. So I have 2 problems that I want you to solve, and then a bonus one for anyone who's up for it. So I will write those problems on the board real quick, and then I will explain them. All right, so these are the 2 problems that I want you all to work on, and then a bonus for anyone who feels up for the challenge. So the first one should be pretty straightforward and easy. What is T5? And what I'm really asking when I say what is T5, what does T5 equal? Just like I have all these diagrams, how many number of dots are going to be in T5? Now you can just draw that out, of course, and just, copy the diagram as you see it. But in order to answer B, you're going to have to really understand, again, the pattern that's happening in these diagrams, because for part B, I'm asking for a formula. Like we did with the square numbers, we came up with a formula so that I could give you any number you could plug it in for n and tell me what that square number would be. Well, now I want the same idea. I want to be able to give you any number, n, plug it into some formula that's going to tell me how many dots, right, are in this diagram. And that, it's not the easiest thing in the world to figure out, but I think you all are more than capable of doing that. So, just answer those two and explain in words your reasoning. So, for T5, I'm okay with just an answer. But for B, I want you to sort of explain how you came up with that formula. What was your process? What was your strategy of tackling it, and how confident are you in it? Even if you don't have a formula that works, if you just tell me your reasoning, what you tried and what failed, I'll be happy enough with that. I just want to see your attempt in tackling this problem. And then finally, for the bonus one, 435 is a triangular number. Which one? So when I say a triangular number, what I mean is, 3 is a triangular number, 6 is a triangular number, 10, a number that I can create a diagram of dots out of. So, as I've written here, I can create a diagram with a certain number of, with a specific n that's going to total 435 dots. So what's the n? Really, essentially what you're solving for is n. So if we come up here, the equivalent of this would be like, for example, if I said 144 is a square number, which one, in other words, what n? Well, if I'm working backwards, right, to square a number, the inverse, as we call it in math, is to take the square root, right? And that would be 12, and so that tells me that S sub 12 equals 144, right? So that's working backwards, and that's what I want you to be able to do with the triangular numbers. Really, if you end up with a good formula for B, then the bonus problem shouldn't be too tricky. But yeah, so that's essentially it. Study these 3 diagrams, figure out how they're growing, and then try to come up with a formula if you can and explain your reasoning. I will post a video with the solution at the end of the week for anyone who's interested, and I will explain how the pattern works and or how the formula works based off of the pattern that we're seeing with these diagrams. Yeah, and that's it. Thank you.